All right, this is Group 4, Chapter 10, Enable Fast and Reliable Automated Testing. In this presentation, we'll be covering the importance and benefits of having automated testing in our work. By using and developing an automated testing suite, our work will move faster and come out more reliable. Continuously build, test, and integrate our code and environments. The staple of a quality product is the absence of simple errors. Developers do this by automating feedback loops in their work. The coined term for this entire process is development pipeline. Some benefits of doing this are detect issues early on, fix problems quickly with few constraints, ensure all code that is deployed has been checked, build fast and reliable automated validation test suite. So slow and periodic feedback kills. Using automated testing suites is incredibly helpful for improving speed and reliability. In order to effectively use those automated testing suites, they should be running continuously versus periodically. Running the automated tests periodically will result in more broken code due to larger quantities being tested. Catch errors as early in our automated testing as possible. The example here illustrates that in an ideal testing suite, most of the errors are caught during the unit test. Inversely, in many testing programs, the focus is in the manual and integration testing. Many difficult or expensive architecture can be avoided using the ideal method. Ensure tests run quickly in parallel if necessary. The faster you run a test and the more tests you run, the more frequent the releases and the more errors you will find. The testing environment will provide an immediate speech, which means that every test that will run serially is a cost that can be avoided. Every test run in parallel is an opportunity to test your application better and faster at the same time. Before we write the code, test-driven development. Kent Beck used this technique in the late 90s as part of extreme programming that has the following 3 steps. Ensure the tests fail, ensure the tests pass, refactor both new and old code to make it well-structured. This automated test provides a living, up-to-date specification of the systems. Automate as many of our manual tests as possible. Automate testing is important testing activity during the software development because it can provide quick feedback to the team when a new feature has been developed. If they do the tests right, it can be very beneficial to the team. Both of the automated and manual tests needed as each serves a different purpose. Automated tests are a set of instructions written by a person to do a specific task, while manual testing, tester's brain is engaged and can spot other failures in the system. Performance testing into our suite. When a software test case covers more than one unit, it is considered an integration test. When developing a software test case, the lines between unit tests can quickly evolve into integration tests. Integrate non-functional requirements testing into our test suite. Non-functional requirements are validating every other attribute of the system we care about. We want to enforce the consistency and correctness of the following: supporting applications, databases, libraries, etc., language interpretations, compilers, etc., operating systems, and all dependencies. Using infrastructure as code management tools allows us to use the same testing framework for testing our environments as we do to test our code. We should also run security hardening checks as part of our automated test to make sure that everything is configured securely and correctly. Pull our and-in cord when the development pipeline breaks. We need to create a visual and-in cord by making sure that when something breaks, we notify the whole team and work together to fix it before any new code is introduced. We can fix problems by either looking at the code for errors or rolling back our work to a previous version. Although when later stages of development pipeline fail, we don't have everyone stop what they are doing and fix it. We have developers and testers on call who fix the problem immediately. By creating highly visible indicators, the whole team can then see when the build or automated tests fail. Why we need to pull the and-in cord. Considering the following situation: someone checks in code that breaks the build on our automated tests, but no one fixes it. Someone else checks in another change onto the broken build, which also doesn't pass our automated tests, but no one sees the failing test results, which would enable us to see the new defect, let alone fix it. Our existing tests don't run reliably, so we are very unlikely to build new tests. By creating a virtual and-in cord, we avoid the possibility of our code getting more and more broken to the point of having to scrap the project and start over again. If we do not have an and/or cord to pull, it could also take weeks and even months to recreate what needs to be recreated for the code to work fully again. In conclusion, in this chapter, we explored how creating a comprehensive set of automated tests helps to confirm that we have a green build that is still in working order. We also explored how to organize test suites and testing activities and how to implement them into the deployment pipeline. We also went over how the and court is a critical part of the production of our code and how to get back into the green build state if someone introduces a change that breaks any of our automated testing. Thanks for watching.